more factoring and getting to solving larger polynomial equations. Factor by grouping, we need to talk about. That's what we've been doing for a long time. We're just going to see it with bigger exponents, higher degree equations, and we'll talk about what quadratic form is in there. And then we need to make sure we know the difference between equations and when we're talking about the equation, when we're talking about a function, when we're talking about solutions and zeros. They're sort of interchangeable, but not quite. So we want to make sure that you know what I mean when I say quadratic form and what different ways we know how to solve a quadratic equation. All right, so here is a 5th degree polynomial equation, and I've got it written as an equation on the left, set equal to 0. It's in standard form on the left, and then it's equal to 0. And then on the right, I've got it written as a polynomial function. So the difference, we've got a 0 on one of them, on one side of the equal sign, and we've got f of x on the other. Now I want to talk about the function first. Remember, it's just often another way to represent it is this, and it's a little easier sometimes for you to think about it when it's equal to y. So what the difference between these two is, we plugged in a 0 in place of y. So when we're dealing with functions, we're going to be asked to find the zeros, which are the x-intercepts. Well, when we're just solving a polynomial function or equation that's set equal to 0, it's another way to say find the x-intercepts. So they're related, they're just not exactly the same thing. It's like talking about the same kind of thing from different angles. The solutions to the equation are the x-intercepts. The zeros of a function are the x-intercepts. So when we're solving the equation, we're going to follow all the same things that we've done when we've done factoring before, because we're going to try to factor first. And so we're going to factor out, these things happen to have a 4x in them. When I factor out that 4x, I'm going to have x to the 4th minus 10x squared plus 9. Make sure that works. Yep, that works. That thing in the middle is not something we've factored before, but I want you to think about what would you do if it was this in the middle instead. Try to factor that before I do. What would that be factored? That would be x minus 9, x minus 1. So if that x to the 4th wasn't there and that squared wasn't on the x, it'd be easy enough. But that's just a trinomial in quadratic form. That first thing, instead of being x squared, and that middle thing, instead of just being x, this is x squared squared. And there's an x squared on that. So it doesn't matter what that thing is, as long as these guys are the same and this first term has a squared, that's going to be considered quadratic form. So now we're just going to continue to factor this in the same way. It's just instead of those first terms being an x, they're going to be an x squared. And then minus 9 minus 1. So that's what that trinomial factors to. So quadratic form is when it's something squared, and then the middle term is also squared. That same variable, same degree. So back to our original problem. It didn't say factor and solve, but we're always going to try to factor first. It's a 5th degree equation, so we kind of expect 5 answers. Well, one of my answers is going to be 0. So there's one of my answers. And these guys in the middle, you can think of in 2 ways. You can think of them as being factorable, difference of squares, or I'll show you on the next one, you can also think of them as something that you can do by taking the square root. So before we get there, try to remember what I mean by that. So I have 5 solutions. Those are the 5 solutions to this equation. Or another way to say it is, if I'm looking at that as a function, those are the 5 zeros. So those are the 5 places that this function would cross the x-axis. Cross or touch. In this case, cross. So this one's going to be, we're going to be able to factor by grouping. And I haven't insisted on those terms before, but that's what we've been doing. When I've been reading some of your summaries, many of you say, well, do the box or do the magic X. When we've been factoring by grouping. If you unfoil or undouble distribute or use the box or use the magic X, what you've been doing is factor by grouping. So this one is just a little bit different application of factor by grouping, but I would really appreciate if you would stop saying, you know, do the box or do the magic X. Start using the correct vocabulary, factor by grouping. So why is it factor by grouping? Well, this one, it's not quite the same thing because we have 4 terms in our polynomial. So it's not just a matter of A times C, but if you'll notice, I noticed that these guys have something in common and these guys have something in common. And factor by grouping at this level will work when I can get the same item in both of those places. So since we've been doing things with the box, I'll do it with the box. It's still just factor by grouping. If you like doing FOIL, the same thing works with unfoiling or doing the horizontal, the lightning bolt method. So I'm just going to put these 2 here and see if I can pull out something, and then put these 2 here and see if this thing works the way I expect it to work. Well, I can pull an X out of those 2. I can pull a -9 out of those 2. I can pull an X out of there, and I can pull a 7 out of there. So what I need to make sure, oh, my 7x squared, that's an x squared. There we go. What I need to make sure is if I multiplied those things, would I get that answer back? So let me just double check. So x times x squared is x to the 3rd. X times -9, -9x. X squared times 7, 7x squared. 7 times -9, -63. So yeah, factor by grouping worked there. So, but I got to make sure I'm done. So far what I've got is x squared minus 9 times x plus 7 equals 0. I might be done, I might not. When I look at this, I go, no, not done. I recognize that. I know I can keep going. So every step along the way now, you need to consider, am I done or do I need to keep going? Now, that one I could factor that quickly because it was difference of squares. I know my answers are -3, +3, and -7. So those are my 3 solutions. So factor by grouping, we still just put the things into the box and see if it works. It won't always work. Some of these won't work, but that one did. There was no greatest common factor to pull out. That should be the first thing we should always look for. We have a trinomial, but all of them have x squareds in them. And what else do they have in common? They also have a 3 in common. So 3x squared I can factor out. 3x squared times 2x squared gives me 6x to the 4th. 3x squared times -9x gives me -27x cubed. And 3x squared times +5 gives me that. So this time, when I factored out my greatest common factor, I have a trinomial in there. So I could try to factor it. That's one of our ways to solve quadratics. So ways to solve quadratics. The last time we had x squared minus 9, we knew it was a special pattern, but really we still just factored. So we're always going to try to factor, or at least I am, when I have a quadratic. But if we can't factor it, the other ways to do it are quadratic formula, completing the square, and taking the square root. We haven't seen that for a while, but that'll come into play on this one. So when I look, I have two quadratics. I have 3x squared. Well, 3x squared, that one, I would divide by my coefficient and take the square root. Plus and minus 0 is still just 0, so x equals 0. So whenever we have x or x squared or x cubed or whatever out there, one of our answers is going to be 0. So that's part of our answer. But this middle thing, I can try to factor it. 2 times 5 is 10. Factors of 10 that add up to -9. Nope, doesn't work. So I've got to use the quad formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And so we're going to plug in our numbers there. Negative b plus or minus square root b squared minus 4ac all over 2a. b is -9, a is 2, and c is 5. So we have x equals 9 plus or minus the square root of 81 minus 40 over 4. Remember, we can't do anything with that denominator until after the square root is simplified. X equals 9 plus or minus square root of 41 over 4. 41's prime, nothing's going to come out, can't do anything with that 4. So those are my other two answers. So those are my 3 solutions. And I could get a decimal for these. These are real numbers. It's going to be irrational. Square root of 41 keeps going forever. But it can be, we could find them. So my 3 answers, x equals 0, x equals 9 plus square root of 41 over 4. And I'm not saying you have to split these. I'm just trying to remind you that this is why there's 3 answers. Those are my 3 answers. Okay, this one, not in standard form. We got to get it equal to 0, and we want to get it in descending order of our exponents. So I'm going to subtract 14x from both sides, or x cubed, I should say. So that one, now we're in standard form, and so I notice I can just pull an x out of everything, and a 2. So a 2x can come out. I'm still going to have a trinomial. So 2x, this is going to be x to the 4th. This is going to be 7x squared. And this is going to be 12. And I recognize this in there. And I know that that factors to x plus, minus 3x minus 4. So the only difference, instead of it being x, this thing is squared and this thing is squared. So these are going to be squared. So the next thing I'm going to do is I'm going to factor that quadratic form trinomial, and it's going to be x squared minus 4 and x squared minus 3. So am I done? Ready to set these equal to 0? Not quite. Or maybe you think you are. Okay, I'm going to do this one first. So when I say I've got to set that equal to 0, if I set that equal to 0, I mean, I guess I could do the quadratic formula, but way easier to just take the square root. Square root, don't forget your plus and minus. So x equals positive and negative square root of 3. Those are 2 of my solutions. 1.717 something something. So that's 2 of them. Now you might think to do the same thing here. And that's one possibility. You might try to do the quad formula. You might, I would factor it personally, but let me show you. What if I didn't recognize that it was difference of squares? I could still do this. This blew my mind when I figured this out when I went back to school. That it's the same thing. Whether I factor that or take the square root, I get plus and minus 2. It's a whole number this time. So there's 2 more solutions, and it was a 5th degree polynomial. So I still have this guy, and that's 0. Divide both sides by 2. So those are my 5 solutions. I have 0, I have 2, I have negative 2, I have 3, no, not 3, square root of 3, and I have negative square root of 3. I wouldn't necessarily write it all out like that, but I just want you to see that there are 5 of them. So factor by grouping, it's the proper name for what we've been doing with the box. Or if you do the horizontal method, same thing. Quadratic form, that first thing can just be anything squared. The middle variable just has to be that same thing that got squared. Equation versus function and solutions versus 0. I think I talked more about that in the previous video, but hopefully you can answer that.